In this ChemPlayer we will be extracting piperine from peppercorns. White pepper is the best to use because it usually contains a higher percentage of piperine and less resin, but we're going to use black pepper. We're starting with 100 grams of black peppercorns. Actually, these are known as Asian red peppercorns and have a slightly brown color. Our first job is to grind these up as fine as possible. We used a coffee grinder to first grind the peppercorns into a powder, then placed this through a fine sieve in order to get the really fine portion of the powder, like this. Be careful when dealing with the fine powder because it easily gets everywhere, and although it has an amazing aroma, it is not too great when you get it in your eyes or nose. The residual coarse pepper is collected, placed back into the grinder and then passed through the sieve again. The last bit of coarse pepper is just added to the mixture. Here's what we ended up with after the grinding and sieving process. Now you need to find a large container that will easily hold 500 to 600 ml of liquid. It also needs to be microwavable, i.e., having no metal parts. We used this large wide-neck conical flask. Using a funnel, transfer the finely ground pepper into the container. Then prepare 150 ml of absolute ethanol. Our ethanol is slightly yellow as it was previously recycled from another pepper extraction. Apparently isopropyl alcohol also works in this process, but we've not tried this ourselves. Add the alcohol to the container with the pepper, and slosh it around to form a slurry of pepper. Some will stick to the sides, but this is okay. Now for our microwave extraction, we used a regular kitchen microwave set on a 400-watt power level. The reason for the large container is so that if the alcohol boils it will be contained safely. Start heating the mixture, but be careful not to overheat and boil the mixture. You will probably get a little bit of bumping in the container as the mixture heats up, but nothing too serious. When the mixture boils, allow to cool and then repeat the process several times. We estimate we got about 4 to 5 minutes total microwave heating exposure time. This is what the mixture looks like when it's been thoroughly cooked. Allow this to cool down a bit. Then we filter the mixture. We used a sinter because it's cleaner, but a normal filter paper will work as well. You can see the nice yellow-brown color of the alcoholic filtrate. Get as much liquid as you can out of the solids using a vacuum. Then prepare a further 100 ml of ethanol and place it in the container we used before. Add the filtered pepper powder out of the filter to this and swirl again to get a slurry. We repeated the microwave extraction process again on this, in order to get as much of the piperine out as possible. Allow the boiling mixture to cool down a bit, and then filter this as before, collecting the yellow alcoholic filtrate. We then washed the solids with another 50 ml of ethanol. We ended up with about 250 ml of brown filtrate from the two extractions. We now need to distill off the ethanol, so place this into a 500 ml flask and set up for simple distillation. We can also use some of the ethanol we recover later on. Distillation is pretty fast. Ethanol has an interesting property of not looking like it's boiling much, when actually a lot of vapor is coming off. After an hour we've distilled most of the liquid. Only about 15 to 20 ml of liquid remain in the flask, so stop heating and allow to cool. Here's the ethanol recovered. We have recycled ethanol from this extraction successfully more than 5 times in a row. Just topping up each time with a little more as needed. This ethanol is also very useful for cleaning glassware, as piperine is extremely hydrophobic and difficult to wash off using water. So use 40 ml of the recovered ethanol, and place into a 200 ml beaker. Now weigh out 6 grams of solid potassium hydroxide, and add this to the ethanol. Stir to dissolve, or use a magnetic stir bar. This may take some time. Here's the result: an ethanolic potassium hydroxide solution. To this, carefully add the 15 or so ml of liquid that remained in the distillation flask. Use a couple of 5 ml portions of the recovered ethanol to wash out the flask, and add the washings to the beaker as well. You will see some dark brown solid collecting in the bottom of the beaker. This is a mixture of fats, peptides, resins, etc. from the pepper, and we'll need to filter this out if we want a good quality product. We used a grade 4 sinter for this, but you could try filter paper, or even allowing the mixture to settle and decanting. Filter the mixture and be sure to wash the beaker and the solids in the filter with a couple of small portions of ethanol as before, in order to transfer all the alcohol-soluble piperine over. You can see the black terry solid left in the filter. It's pretty unpleasant stuff, and one advantage of using white pepper is that this is minimal, even to the point that you can skip this filter stage altogether. Here's the dark brown filtrate. Transfer this back into a 200 ml beaker, and wash the filter flask out with a couple of small portions of ethanol. You should now have around 75 ml of liquid altogether. Prepare a beaker of water and a dropper. Now, slowly dropwise add the water to the alcoholic piperine solution in the large beaker. You'll see a white or yellow fine precipitate forming. This precipitate will sink to the bottom of the beaker, and you'll see a massive crystal starting to appear at the bottom. Keep slowly adding the water as long as you see a white cloudy product being produced on addition. At this point we're done. Chill the mixture down and leave for a good 24 hours to crystallize properly. Here we are 24 hours later. You can see lots of yellow solid in the beaker. Filter off the yellow solid. Note that this may take a little while, as the precipitate is still quite fine. Some procedures tell you to wash with cold acetone, but we've found this dissolves the product quite well and leads to a considerable loss, so we just leave it on the pump to dry as long we can. Here's our still wet crude product from the filter. We put this into a desiccator over anhydrous calcium chloride for a week to dry it out thoroughly. And here's the result: 3.6 grams of crude piperine. We obviously lost some product in the process, but this means that the original pepper contains at least 3.6% piperine. You could recrystallize this, but if you want to hydrolyze and go to piperic acid, you can perform that reaction directly on this product quite successfully. Don't forget that an interesting side product of the hydrolysis is piperidine, which you can extract from the alcoholic distillate by gassing with hydrogen chloride and then evaporating the resulting solution. Here's a couple of grams of piperidine hydrochloride. We prepared in exactly this way, starting from pepper. It is possible